Hello friends, first of all welcome of all of you in this video lecture series of 11th Commerce Economics. Before starting this lecture, I just revised what we studied in before this video lecture. We completed second topic, that is money exercise. Okay, so through this video lecture we start the chapter number 3, that is partition value. So my question is, what is meant by partition? Partition, that is dividation. So the procedure of dividing the numerical data or the data in terms of numbers, into equal parts is called as partitioning. Means the procedure of dividing the data into equal parts is known as partitioning, and values dividing the data into required number of parts, that is procedure of dividing the numerical data, procedure of dividing the numerical data into equal parts known as a partitioning or dividing. But the values dividing the data into required number of equal parts, are called as a partition values. So first we just revised what we studied in 10th standard or up to 10th standard in mathematics as a part of mathematics of 10th standard. First of all, let's recall. First question, are you familiar with the word averages? So how to calculate average? Average is equal to sum of observations divided by number of observations. Sum of observations or summation of all observations or summation of all numerical data given divided by number of observations. Next, can you tell the meaning of individual series, discrete data and continuous data? Individual series, discrete data and continuous series. So I revised here what is by individual series. Individual series is also known as simple series. When a single type of information or simple information is given, it is known as an individual series. For example, when the information is given about only one characteristics, is called as simple series or individual series. When a single type of information is given, it is known as individual series. For example, marks in accountancy, marks in OCM, height of students, weight of students. That is a single type of information is given. For example, marks in accountancy 50, 55, 60, 70, 80, 90, 45, 40. That is a single type of information is given. Means in this information or in this data or in individual series, only a single type of information is given. Okay, another example, that is, I repeat, height of students, weight of students, marks in accountancy, marks in OCM, marks in SP, marks in economics, marks in mathematics, marks in civics, marks in history. So this is a single type of information is given, that is the individual series. Next, discrete data. Discrete series or discrete data, that is when two types of information is given, when two types of info, in short, when two types of information is given, it is known as discrete series. When two types of information is given, it is known as discrete series. For example, in simple series, or in individual series, only a single type of information is given, that is, for example, marks in accountancy, so along with these marks, if number of students is also given, then there is known as two types of information. For example, when the size of item, that is marks in accountancy, for example, size of item in bracket marks in accountancy, and number of frequency are given, for example, number of students, such series is known as a discrete series. So in individual series, only marks in accountancy is given, for example 50, 55, 60, 70, 80, 90, 45 and 40. But in discrete series, along with the marks, the number of students is also given. For example, first column shows marks in account, for example 50, then how many students in the class scored 50 marks in accountancy, that is the second column, that is frequency is 10. Next, if marks in accountancy, the size of item is 65, and how many students scored 65 marks, the answer is 15, that is number of students is 15. That is two types of information is given. First information is marks in accountancy, and second information, that is number of students. Both information is given, known as a discrete series, or in simple language, when two types of information is given. And next, continuous series, that is when series is represented by classes and frequency, it is known as a continuous series. That is class or group. The data is divided into class or group, that is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. The classes or groups is make like that, that is 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. And frequency, that is number of students is given, that is in between 0 to 10 there are 10 students, between 10 to 20 there are 15 students, between 20 to 30 there are 9 students, between 30 to 40 there are 7 students, between 40 to 50 there are again 3 students. So like that way, okay, classes, or it is known as grouped data. Again, this continuous series is known as a grouped data. That is, group is given along with the number of students, or in other words frequency is given. Then next important concept of this topic, that is class. What is meant by class? When two values forming a group is known as a class. For example, 0 to 10, 10 to 20, 20 to 30. That is a class. Next, class limit. Okay, so class limit is related to the class limit is related to the class. What is meant by class? I repeat again, I repeat here, two values, the two values forming a group is known as a class. That is 0 to 10, 10 to 20, 20 to 30. Okay, so in class 0 to 10, in class 0 to 10, 0 is the lower limit and 10 is the upper limit. 0 is the lower limit and 10 is the upper limit. In class 10 to 20, 10 is the lower limit and 20 is the upper limit. 20 is the upper limit. Next concept, mid value or midpoints. Next concept, mid value or midpoints. Okay, so mid value or midpoints is equal to lower limit plus upper limit divided by 2. Lower limit plus upper limit divided by 2, known as a mid value or midpoints. So for example, that is a class is given 10 to 20. So here 10 is a lower limit. 10 is a lower limit. 10 is a lower limit and 20 is a upper limit. So 10 plus 20, 10 plus 20 divided by 2, 10 plus 20 divided by 2 is the mid value or midpoint. Mid value or midpoint. Next concept, that is class interval. Next concept, that is class interval. The difference between, listen carefully, the difference between upper limit, the difference between upper limit and lower limit of the class is called as a class interval. The difference between upper limit and lower limit of the class is known as a class interval. For example, in the given class, if the given class is 10, if the given class is 10 to 20, so here upper limit is 20 and lower limit is 10. Upper limit is 20 and lower limit is 10. So 20 minus 10, 20 minus 10, that is upper limit minus lower limit. Upper limit minus lower limit, this is 20 minus 10 is equal to 20 minus 10 is equal to 10 is the class interval. Next concept, frequency, class frequency. Okay, the number of items belonging to each class, the number of items belonging to each class is called as a class frequency. The number of items belonging to each class is called as a class frequency. For example, if marks of student is given in terms of group data or in terms of class, for example, marks of student is given in like a way, that is a 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. So in between 0 to 10 there are 5 students. So the frequency of the class 0 to 10 is 5. So in between 10 to 20 marks obtained by students, in between 10 to 20 is 15. Marks obtained by students in between 10 to 20 is 15 students. So the frequency of the class 10 to 20 is 15. Okay. Next, if marks obtained by students in between 20 to 30, in between 20 to 30 is 20 students, is 20 students. So here 20 is the frequency of the class 20 to 30. Okay, so that is the in case of individual series, discrete series, or ungrouped data, continuous series, or when classes is given or the data is in the format of grouped data is given, that is known as a continuous series. Okay, some types of averages and their formulas in individual series, discrete series, and continuous series is given. For example, formula of arithmetic mean in case of individual series, that is x bar is equal to summation of x upon n. X bar is equal to, in case of discrete, summation of f1 x1 upon n. And in case of discrete series, in case of continuous series, when grouped data is given in that is in direct method, x bar is equal to summation of f1 x1 upon n. Mode means in individual series, value repeated maximum number of times. Mode, that is value repeated maximum number of times. In discrete series, the value which has maximum frequency. And in continuous series, mode is equal to L plus into bracket f1 minus f0 upon 2f1 minus f0 minus f2 bracket complete into h. So here L stands for, lower limit of the class. L stands for lower limit of the class. Fi or f1 stands for frequency of class. Frequency of the class. f0 stands for frequency of previous class. f0 stands for frequency of previous class. f2 stands for frequency of next class. f2 stands for frequency of next class. And I or h into I, or it is also known as h. Okay, I or h stands for interval of model class. Interval of model class, or interval between the class, that is class interval, that is upper limit minus lower limit. Upper limit minus lower limit. Okay, next, median. M is equal to size of into bracket n plus 1 upon 2 observation. Here n stands for that is number of observations given, that is number of observations given. For example, if observations are given in like a way 5 6 7 1 2 3 4 5 6 7 8, so observations are eighth, so eighth plus 1 upon 2 is equal to median in case of individual series. In case of individual series, okay, so in case of discrete data or ungrouped series, in case of discrete data or ungrouped series, the formula is again same, that is size of n plus 1 upon second observation. So in case of continuous data or grouped series, or when the data is given as per classes, that is 0 to 10, 10 to 20, 10 to 20, 20 to 30, 30 to 40, like such a way. So in such case, median is equal to m is equal to L, that is lower limit of the class, plus n, that is n upon 2 minus CF. CF means cumulative frequencies. How to calculate cumulative frequencies? We discuss this concept when we move towards the next part of the same topic, that is when we practically calculate the quartiles, deciles and percentiles in continuous series. F, that is frequency of that class, and H or I, that is class interval or upper limit minus lower limit, in simple words, class interval. So introductory part, the procedure of dividing the data into equal parts, the procedure of dividing the data into equal parts is called as partitioning, is called as partitioning, and values dividing the data into required number of equal parts, values dividing the data into values dividing the data into required number of equal parts are called as partition value, are called as partition value. All the things which we discuss, that is arithmetic mean, mode and median in individual series, in discrete series and in continuous series, all these things we discussed so far, we already studied in 10th standard. That is how to calculate mean, mode and median in individual series when a single type of information is given, discrete series when two types of information is given, and continuous series when the data is given in group series, that is in class, the data is given as per classes, or in class, that is 0 to 10, 10 to 20, 20 to 30, like that way. So in class 10th, all of you studied about the measures of central tendency, that is averages such as arithmetic mean, median and mode. Median is the value of middlemost observation in the data when the observations are arranged in increasing or decreasing order of values. Median is a special type of partition value because there are equal number of observations above as well as below it. Median, what is by median? Median, that is the most middlemost observation, that is the median. So the data is divided into the data is divided into two equal parts. The data is divided into two equal parts, and the value which we find as a median, so below that value and above that value there are equal number of observations. So like median, quartiles, deciles and percentiles are also partition values, since they divide the given set of observations into equal number of parts. They divide the given set of observations or given data into equal number of parts. In general, they are referred to as fractals. Partition values form a part of descriptive statistics. Partition values form a part of descriptive statistics. In the forthcoming chapters, that is population, unemployment, poverty, students will get a proper application of the third topic, that is calculation of quartiles, deciles and percentiles. That is, the data is given relating to the population, unemployment and poverty, and we have to calculate with the help of that particular data of population, unemployment and poverty, and we find out quartiles, deciles and percentiles. That is, we use the partition values in that economic data analysis. We use that partition values, that is in economic data analysis. Okay, so statistics day, Professor P.C. Mahalanobis, an Indian statistician, was formulating India's strategy for industrialization in second five plan. After independence, Indian government adopted a plan economy for India. This plan consists a plan of 5 years. But when Modi government come into power in 2014, when Modi government come into power in 2014, they instead or in place of planning commission, they form a new organization, that is Niti Aayog, National Institute for Transformative India. So P.C. Mahalanobis play an important role in formulating the policy of second five plan, which gives a boost or target of industrial development between 1956 to 61, and after this plan, this second five plan is known as a Mahalanobis model. So what is the contribution of P.C. Mahalanobis in statistics? So Mahalanobis devised a measure of comparison between two data sets, that is known as a Mahalanobis distance. That is comparison between two data in case of not a data in words, but data in terms of numerical data or data in terms of numbers. So comparison between two data sets, that is known as a Mahalanobis distance. He also devised a statistical method called fractal graphical analysis. He also devised or propounded one concept, that is a statistical method called fractal graphical analysis, which is used to compare the socio-economic conditions of different group of peoples. Socio-economic conditions of different group of people. So take into consideration the contribution of Mr. P.C. Mahalanobis, an Indian statistician. The government of India has dis- celebrate 29th of June every year as a statistics day, as a birth, which is the birthday of Mr. P.C. Mahalanobis at a national level. That is, a national statistics day was celebrated on 29th of June every year as a birthday of P.C. Mahalanobis, which is Indian statistician. Okay, so the next part, need of partition value. Need of partition value. The data, that is a numerical data, the data that is a numerical data consists of extreme values on the lower side and also on the higher side in magnitude. Such values are known as outliers. So the average used for such data often misinterprets its representative values. To overcome this misinterpretation, generally partition values like median, quartiles, and deciles are prescribed or used. Okay, so the data consists of values, that is lower side values, or that is extreme values and lowest values. But the average of such values always represents, that is misinterpretation. The average used for such data, it always misinterprets its representative values. To overcome this misinterpretation, generally the partition value, that is dividing value, or dividing the given numerical data into different parts, okay, such as partition values like median, quartiles, and deciles and percentiles are used. Median, quartiles, deciles, and percentiles are used. Okay, next, always remember Q2, that is second quartile, is equal to D5, fifth decile, is equal to P15, P50, that is percentile 50 is equal to median, that is second quartile, fifth decile, and 50th percentile is equal to median. Next, Application of quartiles, deciles, and percentiles in economics. Application of quartiles, deciles, and percentiles in economics. Quartiles. Quartiles are used in the study of all types of financial information. Quartiles are used in the study of all types of financial information relating to economic data, income data, stocks data, that is share market, in sales, in surveys. Income quartiles is the most objective method of comparing changes among individual income group caused by economic changes such as wages and wage fluctuations and inflation. Inflation means rise in the general price level of commodities or goods, that is inflation. Deciles have wide application in finance and economics. Deciles have wide application in finance and in economics. Government uses deciles to study the level of economic inequality. Deciles Government uses deciles to study the level of economic inequality, measurement of poverty line and drought condition, etc. Also, deciles are used in investment, particularly to assess the performance of portfolio investments such as group of mutual funds. Percentiles are used to make results, test scores, health indicators, household income. So these are the some useful information, that is practical application of the values, that is partitioning values, that is deciles, percentiles, and quartiles. Okay, so take into consideration the practical application of all these things. Take into consideration the practical application of all these things in next video lecture. This is only a theoretical part of the topic. Okay, I want to cover the maximum theory of the topic. Okay, because from next video lecture we start only a practical calculation part of the topic, that is how to calculate quartiles, how to calculate deciles, how to calculate percentiles, what is meant by Q1, Q2, Q3, what are the formulas for calculation of Q1, Q2, and Q3, what is meant by deciles, what is meant by percentiles. Okay, so first you take into consideration the practical application while studying this particular topic. Your approach must be a practical approach. Your approach must be a practical approach, because all the things which you are going to study under this topic, that is quartile, percentile, and deciles, and their practical applications and calculations are useful in your future also. Okay, when you become a chartered financial analyst, investment advisor, portfolio manager, finance manager, so at that time all the things that you studied in 11th economics in third topic are very much useful to all of you. So please keep in mind all these things, and okay, and ready for calculation part of the topic.